Hello scholars, welcome back. Today is, well, I'm filming this on May 5th. Happy Cinco de Mayo. But you're watching this on May 7th, Thursday. Thank you for doing skill 44-46 assessment. My favorite part of the whole assessment was not so much about math, but about the last bonus question of reading how you guys are doing. I appreciate all your Netflix suggestions. I need to watch one by one. What have I been doing past few weeks? I've been kind of on TLC, the channel marathon, all the reality show. That's the weird well, I wouldn't use the word weird, but all those reality shows. So I watch House Hunters, Say Yes to the Dress, For Weddings, Our Daughters. It's about this family had 4 quintlets. Is that quintlet? I should know this as a math teacher. And 90 Days Fiance, all that stuff. So I've been just trying to escape from the reality by watching weird reality shows. So that's been my life. Yeah. So we have, can you guys believe we have like 5 lessons left, including today? That just sounds crazy. So we're on the last, what's the word? Last end of it. So let's get through it. We can do it. Today I would like to go over the last question from the assessment that you took. There were just a lot of you guys didn't get it 100%. Most of you got like all of it except the last part. So that's why I want to go over it, and then we're going to do skill 47 lesson. Okay? All right, so let's look at that last question on your assessment. It was this problem. There's f of x, there's a g of x. Is asked you to find f of x equal to g of x. So I'm going to set those two equal to one another. Log base 3 of x minus 5 plus log base 3 of x is equal to log base 3 of 6 minus 4x. Notice that both sides of the equal sign have the logarithm, so I gotta condense these two. How am I gonna do it? Both of them have log base 3. And I'm gonna go ahead and multiply x minus 5 and x together because both are positive. So x times x minus 5 equal to my right side stay the same. Now what do I do? Notice both of them have log base 3, log base 3. So I'm gonna exponentiate with the base 3. Okay, then I can cancel it out. Then I'm left with x times x minus 5 equal to 6 minus 4x. Distributed x squared minus 5x is equal to 6 minus 4x. I mean, like 98% of you did that until that part. You gotta set, notice this is a quadratic, so you're gonna set it equal to 0 and try to factor. You add 4x to both sides. Then I get x squared minus x is equal to 6, and I subtract 6 from both sides. I get x squared minus x minus 6 equal to 0. About 5 of you made a numerical mistake there. Alright, now I'm going to go ahead and factor it. It's a quadratic trinomial. A times a is negative 6, b is negative 1, 2 numbers, negative 3 and 2. I can take a shortcut. X minus 3 times x plus 2 is equal to 0. Set each factor equal to 0. I get x equal to negative 3, x equal to negative 2. Alright, that's where 90% of you says those are your answer. No. Then what do I need to do? You gotta check your answer. Alright, now guys, when I say check it, I'm not asking you to plug it in to make sure both sides are equal to one another. I mean, when you plug it in, both of them work. Then what are you supposed to check? Well, when you have the logarithm expression, log, I don't know, make it up, log base a of b. Please know that both your bases and the arguments are supposed to be positive numbers. So you cannot have negative base, you cannot have negative argument. So that's what you're checking. So let's go ahead and check x equal to negative 3 first. You got to plug it in your original equation. Original right here, f of x. So I take negative 3, plug it in. What's negative 3 minus 5? That's negative 8. Guys, can I have log base 3 of negative 8? No, I can't. I can't have negative arguments. So just because it did not work for one of them, negative 3 does not work. What about x is equal to 2? I plug it in. First one, 2 minus 5 is negative 3. Can I have log base 3 of negative 2? No. So indeed, this question, there is no solution. That's what you're checking. You're not checking to see both sides are equal to one another. You're checking to see whether you get both positive arguments and the basis. Okay, so please remember that. Alright, so that is done. Now let's go ahead and do the Skill 47 lesson. I'm really excited because I got a new printer. Yay. So I printed this out. Doesn't it look nice? I mean, duh. It's all like clear. I can read it. Like, it's nice. I gotta tell you, one nice thing about doing online e-learning is that I do not have to fight with the school printer. It's really, really nice. The school copier, where, you know, I've been printing like this thick stack of papers every single class for you guys. I don't have to do that anymore, so it's like stress-free, no printer, although I'd rather do that to see you guys than stay home. So there it is, but it is nice. Okay, all right, Skill 47, solving exponential equation. I'm gonna go ahead and then do the step-by-step and then explain you how to do this example and then do a few examples. Here's the thing about math. If you're a Heron Scholar, you're probably familiar with it. Do I like to follow steps? In other words, do I like to teach you how to do things like step by step? I really don't. I think there is a lot of exception, a lot of better way of doing problem, but it really depends on what type of problem you're getting. So that being said, I will explain you step by step, but you're going to notice on all this example, there are going to be a lot of exceptions. So please know that there are always exceptions. All right, so how do I get the exponential, how do you solve the exponential equation? Step number 1, get exponential term by itself. What do I mean by that? I want you to have, by the way, what does exponential means? You have a base, exponent equal to something, something, something. So you have a base and you have an exponent. So when your x is in the exponent, this is called exponential equation. So first step is I want you to have a base and an exponent by itself. So look at the right side. Where is my base and the exponent? Right there, that 2 raised to 3 minus 2x power. So first step is to have that by itself on that one side of the equal sign. Notice there's a 3. How do you get rid of that 3? You subtract 3 from both sides. Then I get 2 raised to 3 minus 2x power is equal to 8. So that is step number 1. Have that exponential form by itself, base and exponent. Nothing else on that equation, on that side of the equation. All right, step number 2, what do I do? Take the logarithm with appropriate base of each side. So you can kind of think of this way. When we are doing logarithm equation on the last lesson, once you got the logarithm, single logarithm by itself, what was the next step? We exponentiated, right? So when it was in the logarithm, you put it in exponential form or took the exponentiated. Now, what do you think you're going to do when you're solving exponential equation? You're going to take the log. So it's kind of, they're like best friends, right? I mean, logarithm and exponential are best friend. So that's how you can think about it. So notice how here I got the exponential form by itself. I'm going to go ahead and take the log on both sides. What kind of base do you think I should use on this example? So I have 2 to the 3 minus 2x power equal to 8. You got to follow this base. So since this is a base 2, I'm going to take base 2 on both sides. So you take log on both sides. Then notice what happened. Using that property, I can cancel this out and I'm left with 3 minus 2x is equal to. On the right side, what is log base 2 of 8? In other words, 2 to the what power gives me 8? 2 to the third power gives me 8. Right? And then step number 3, solve. I'm going to solve for x. So subtract 3. Negative 2x is equal to 0. Divided by negative 2, x is equal to 0. Cool. beauty of the exponential equation, we do not have to check the solution. You don't have to plug it in because you can have negative exponent, you can have positive exponent, it doesn't matter. Okay, so that's how we go. All right, let's look at the example. Which one do you want to do? Let's do this one. Step number, well, notice that I have a base and the exponent right there, that 2 raised to 3 minus 3 minus x power. So I'm going to go ahead and isolate that by itself. So subtract 4 from both sides to get 2 raised to 3 minus x power is equal to 6. Are we good so far? Okay, so step number 1, get the exponential form by itself. Step number 2, since it's an exponential equation, I'm going to take the log. Take the log. So take the log on both sides, but what kind of base should I use? Base with 2. Okay. Why are we using base 2? So that I can just cancel those out and left with 3 minus 2x is equal to, over here guys, 2 to the what power gives me 6? I don't know. I mean, it's probably 2 point something. I don't know what it is. So I'm just going to keep it log base 2 of 6 there. And step number 3, go ahead and solve for x. Subtract 3 from both sides. Then I get negative 2x is equal to log base 2 of 6 minus 3. All right, here's where a lot of you make mistake, guys. Can I just go ahead and do 6 minus 3? No. This is one expression there. So you can't just take the part of the logarithm and then subtract 3. This is a one chunk of it. So if that's confusing to you, go ahead and put the parenthesis around so you can protect it. All right, now let's solve for x. I'm going to divide it by negative 2 on both sides. So x is equal to log base 2 of 6 minus 3 all the way divided by negative 2. Now notice your direction says to round it up, so I can use calculator. So let's go ahead and use my calculator. I'm going to plug it in. How are we going to plug this in your calculator? Using the change of base formula, it's going to be log of 6 divided by log of 2, right? That's argument goes on top, base goes at the bottom, minus 3, and then negative 2 divided by negative 2. So let's go ahead and plug it in. Log of 6 divided by log of 2. If you want, you can just go ahead and hit enter, just do one by one. And then what? Subtract 3, hit enter, and then what? Divided by negative 2. Answer, I get 0.208. 208. Okay, that's how you do it. Let's do one more. This one right here. Where is the exponential form? I just see one right here, e to the x minus first power. That 3 is not a part of it, so you have to get rid of that 3 as well. So how I'm going to do it, subtract 1 from both sides, divided by 3 to get e raised to the x minus first power equal to 3. How do you solve the log exponential form? Oops, I just gave it away. Take the log on both sides. What kind of log would you take on this one? Notice your base is e, so can I go ahead and take natural log on both sides? Yep, I can. Then natural log of e is 1, so I get x minus 1 is equal to natural log of 3, add 1 to both sides, x is equal to natural log of 3 plus 1. Can I add that 3 and 1? No, protect it, and then plug it in your calculator. Oops. Natural log of 3, close the parentheses, and then plus 1. I get 2.099. Ooh, 2.099. Alright, now look at this problem. You're probably like, what? I have exponential on both sides. What do you want us to do? I can't separate it. Correct, but look at your bases. Actually, guys, we did this on scale 44. Yeah, 8 and 2. You gotta convert to the common base. What is common base of 8 and 2? 2. 8 is 2 to the what power? Third power. And I distribute it using the exponent rule. So 2 raised to 3x minus third power is equal to 2 raised to 3x plus 4th power. Notice both of them have a base 2. So what kind of log am I going to take? Log base 2 on both sides. You are right. And keep that the same. Maybe you didn't answer me. I don't know. I'm hoping you did. Nope. Alright. And then I can cancel out. Left with 3x minus 3 is equal to 3x plus 4. Subtract 3x from both sides. Negative 3 is equal to 4. And you're like, what? I know I've been in quarantine long enough, but that does not look right. What does that mean in Algebra 1? Yeah. No solution. That means no matter what kind of x we are trying, nothing will make it work. Therefore, no solution. Cool. Alright, next. Alright, I consider these challenge. Challenge, challenge. Both of them. Are you ready? Alright, let's go. Mrs. Major says to separate the exponential by itself. But then you're like, well, there's this one and there's this one. I give up. Haha, don't. I need you to go a little close to it. That's the square. That's the just by itself, linear. And that's the number. Wait a second. Isn't this quadratic trinomial? Do you guys see it? For those who don't see it, what if I write it like this? E to the x power square minus 4 e to the x power minus 5 is equal to 0. Do you guys see how it's a square? It's like a square, ax squared plus bx plus c is equal to 0. It's the same form. Except for regular quadratic, it looks like this. Only difference is that instead of the variable being x, this variable is going to be e to the x power. Okay, so I can just factor it. GCF is 1. I'm going to do AC, B char. A times C is negative 5. B is negative 4. Two numbers, add up negative 5 and 1. Since A value is 1, I can go ahead and take the shortcut. So it's going to be not x minus 5x plus 1. It's going to be e to the x power minus 5 times e to the x power plus 1 is equal to 0, because that's your variable you're using. Then set each factor equal to 0. Then I get e to the x power equal to 5. E to the x power is equal to negative 1. Alright, let's go ahead and solve it. Exponential form by itself, so I can just go ahead and take the log on both sides, probably natural log on both sides. Whoop. X is equal to natural log of 5. I can plug it in my calculator, natural log of 5. 1.609. Are you ready for this? Natural log. Natural log. Boop. X is equal to natural log of negative 1. When you type this, when you write it, that should give you a red flag. You should be like, oh, wait a second. We can't have a negative argument, so that should not be the answer. Correct. Your calculators confirm that. Confirm. There you go. Confirm that for you. So I type natural log of negative 1. It says normal, non-real answers. That means there's no solution. Boop, boop. So only solution is going to be 1.609. Cool. All right, next one. Okay. So this one, both of them are exponential form, left side and the right side of the equal sign. So you're like, oh, I'm kind of thinking something like this, right? So my bases are 8 and 2. I convert to the common base, blah, blah, blah. But then here's a problem. When my bases are 2 and 5, can you come up with any common base? No, you can't. Oh no, then what are you going to do? I'm just going to walk through this problem with you. What you're going to do is you're just going to take the common log on both sides. What do I mean? Just the regular log with the base 10. Okay, Then see what happened. Okay, I'm gonna use that property of dropping that exponent to the forward to get x plus 2 times log of 2 is equal to x minus 3 times log of 5. I'm gonna go ahead and distribute it. X log of 2 plus 2 log of 2 equal to x log of 5 minus 3 log of 5. All right, notice what you have it here. You have these two with the x's and these two without x's. So I'm going to move all the x's on the left side of the equal sign, all the non-x's to the right side of the equal sign to get x log of 2 minus x log of 5, because I just moved that to the other side, equal to, move that to the other side, negative 2 log of 2 minus 3 log of 5. Common factor x, pull it out. Log of 2 minus log of 5 is equal to the same thing, negative 2 log of 2 minus 3 log of 5. How to get x by itself? You're going to divide both sides by this blue thing. So x is equal to negative 2 log of 2 minus 3 log of 5 divided by log of 2 minus log of 5, which looks awfully long, but you can actually plug in your calculator. Negative 2 log of 2 minus 3 log of 5 divided by log of 2 minus log of 5. 6.782. This would have been a great problem to try it. I'll give you candy if you got it right type of problem. Okay. All right, so that is end of skill 47. I mean, the basic ones are pretty easy. There are just a lot of exception. You have 5 IP problems to work on. It looks like pretty easy. I mean, this one is a special case, quadratic. That one is kind of like what I just did, right? So these sort of special one, rest of them are pretty good. Okay, so good luck, and I will see you guys next Tuesday. Oh, if you're watching this on Thursday, just to let you know, it's supposed to be really cold Friday night into Saturday morning. So if you have planted flower outside, you might want to cover it up with the tarp so they don't die. That would be really sad. Okay, all right, bye guys.